All right, so let's talk about DeMorgan's law and basically the theorems that go along with these that go with what you guys were doing earlier this week. So basically there's two more rules. They have to do with inverters. So if I invert the quantity of A or B, so it's a sum, then I would split my line and I would change my sign. So it becomes not A and not B. So it goes from an or to an and then my two inverters get split between my two inputs. Same thing happens at the bottom. If I have an A and B that's been inverted, then I draw a line down it. It becomes not A or not B. So again, it is split the line, change the sign. Just tells you a little bit about who DeMorgan was. He was born in India in 1806 and was pretty instrumental in some of our advancements in mathematics, especially when it comes to logic. So for those of us who really enjoy the proofs behind why these things work, you have not A and B. So if I were to build that out into a circuit, it's going to have the AND gate with an A and B, and then that feeds into an inverter because the whole thing is then inverted. And if I go through doing the truth table that goes along with that, we would realize that it goes from an and then when that and gets inverted, it becomes this. So we have a 1, 1, 1, 0. The equivalent to that is if I do a not A or a not B. So again, we go in and we say, okay, if it's not A, that's a 1, that's a 1, that's a 0, that's a 0. If it's a not B, that's a 1, that's a 0, that's a 1, that's a 0. And so we just inverted everything. So then the last part says, okay, well now we have a not A or not B. So I'll look here and say, okay, well if I have a 1 and a 1, that's a 1. A 1 or 0 is a 1. 0 or 1 is a 1. 0, 0 is a 0. So they do match as far as their equivalency is for their two pieces. Same thing's true if I do a not A or B. Again, they show you what it looks like. They show you what the truth table is. An A or B is 0, 1, 1, 1. If I invert that, it's 1, 0, 0, 0. And they check the other side. If I not the A and B first, those get changed. And then I check to say, okay, if I have a 1 and a 1, it's a 1. If I have a 1 and a 0, it's a 0. And so on and so forth. And again, these two match. So this is just number 20 and 21 of all of your theorems. These are also on your formula sheet. So please feel free to use those as much as you can to try to help you guys be more successful when you're going through these. Because a lot of times we forget what those rules are. Again, they use the term break the line, change the sign. Basically what it means is break the line over the two variables, change the sign that's in between those two variables. And that's really all you're doing. So it gets into much more complex ones. So if you notice here, we have a very large inverter that goes for the whole quantity. We have a smaller inverter that does a smaller quantity. And they have two regular inverters that just go right over one input. So the very first thing we do when we do these is we're going to break the line, the largest line, and we're going to be able to change that sign. So that was the first step they did. They broke this line here. I'm going to try to get my tools. Okay, so I can break the line here. There it goes. And then that changes the sign. So that's why it becomes the plus sign. And then I've continued that line here and here on both sides. So then again, I'm going to look, okay, if I have a not, that was one of our rules from before. If I have a not like this, okay, don't worry about this little part here, just the top two. They cancel each other out. So it leaves me with an X and a not Y. Here, on the other hand, I saw that long line, nothing to cancel it out with, so what I'm going to do is I'm going to break that line. That leaves me with a not y, change my sign to an and then have a not z. Then last but not least, we've got another not here. Those cancel each other out. And so I'll get left with a y and a not z. Nothing really to simplify here. And then they say, okay, well, we're going to simplify it just a little bit more. So we're going to get rid of all the parentheses and stuff. So then we have a x, not y, or y, not z. All right. It says, so where would you such an odd Boolean expression come from? So take a look at very poorly designed. A lot of times what happens is someone just designs things very poorly. So if we design it correctly with kind of the sum of products in mind, then we're not going to have the issue of having to simplify this. But in some cases, people do, and so we have to try to simplify it as much as possible. Okay. So simplify the output function of this one. Be sure to note that the Boolean or DeMorgan's theorem used at each step. Put the answer in sum of form. So again, the first thing you would do is break this line, split it into two, put a plus sign between the two. You're going to have a double not here or double inverter here. So these will cancel out and you'll have the next y. You would then have to split this guy and you'll have a double x here that's going to cancel out and you'll be left with a not z. So if I look to the next page, that's what they did. They split it here, split those two, canceled out my pieces. Then we split this part, change our sign. We have a not x and a z, a not z. X becomes, well, not x becomes x. My not z comes here, and I have an or between the two, and we just get rid of the parentheses. Hopefully that helps you guys understand the DeMorgan's law a little bit better. If you guys have any questions or confused about any of the steps, please feel free to reach out to me. There are lots of options either through Google Classroom or Zoom or Remind.